Hello guys, very happy morning to all of you. In the previous class we just discussed about what are the normal structures of simple mechanism and inversion, and what are the different type of inversions and physical property, chemical property. It's not about chemical property but how the each and every link works, and it's about, I just told about the crank, the ranker. So what are the different kind of things we are just analyzing. And short plus long term, it means shortest plus longest link less than p plus of q, it means other than two links. So this is called as Grashof law. And it means shortest link connected, it will come as a double crank. And I just told you a bit of extra thing also. Okay, so I think so we will have just 2 minutes of division, and later on you can continue our subject. Okay, so it means I also just told about how to find the longest link length and what is the thing. It means related to the links that has been just procuring. Okay, so next one you can see inversion of 4 point. Inversion means just whenever you just fix one side of the link, it is called as inversions. Okay, that's it. Okay, so it means in the first one side you are just fixing, in other side as you see, and you can see t beta 1 of beta 2, alpha del beta omega, beta 2 of beta 1, this one. Okay, when you just intersect, it means we are just getting quick return ratio as 2 pi minus of alpha divided by alpha. Okay, it means forward time divided by return time. Okay, forward time is 2 pi minus of alpha divided by omega, return time is alpha divided by omega. Okay, so 2 pi alpha, 2 pi minus of alpha divided by alpha. Okay, by changing the geometry of all things we are changing, but how will you find alpha? So so it's a such a, it means an easy thing. Okay, so you can see what's an alpha. Alpha equal to beta plus 180 minus of gamma. So how we will find the beta and gamma? By we will find the beta and gamma by using the cosine's law. Okay, so cosine's law I think so you would have easily known. Okay, so you need to remove only two diagram, this two diagram. Okay, this L1 L4, just okay, so this one, so L1, L2, L3, L4, so this is beta 2, and whenever you just place like this is L1, this is L1, L4 minus of L1, L3 and L2. Okay, this is gamma. So gamma, cos gamma equal to this one, L4 minus of L1 the whole square plus of L2 the whole square minus of opposite L3 the whole square divided by which one, this one. Okay, 2 times of L4 minus of L1 dot product of L2. Okay, I think so you can see this one. Okay, cos beta is this one. From the equation we can find beta and gamma and substitute in the mother equation, and you can find the remaining entire equation. Okay, so quick return ratio equal to 2 pi minus of alpha divided by alpha. This is a normal thing. Okay, so wiper mechanism I just told you, and also just told about the radius plus of eccentricity less than or equal to length of the connecting node. Radius plus eccentricity less than or equal to length of connecting node. Okay, okay, so you can just go for the next thing. So it means you can see guys here, if eccentricity is 0 means it is inline slider carrying mechanism. If eccentricity is little bit of distance, it is called the offset slider carrying mechanism. Okay, so parallel slider carrying mechanism and neutrality and everything we need to just consider. Okay, slow slider crank and crank slider. Okay, just a normal thing. So next one I just told about the stroke length. Okay, stroke length. So stroke length means how much the piston is able to move. Okay, from extreme left portion to the extreme right portion. So extreme right portion to the extreme left portion. Okay, extreme right is L plus of R. Okay, this side, and extreme left is L minus of R. Okay, I think so you can understand. So the distance between extreme right portion and extreme left portion is called as stroke length. Okay, so whenever you just minus, you can see stroke length is 2 times of radius, only for inline slider mechanism. Okay, no need to confuse any kind of other thing, only this is for inline slider mechanism. So forward I think so you can understand. Okay, it means for that inline if stroke length is 2 pi, it means 2 times of radius, the quick return ratio is generally 1. Okay, next one is offset. So offset means it is now a little bit of distance. Okay, so now when it is a little bit of distance, I think you can understand. So L of R, this one L of R, and this one is C. Okay, So L plus R the whole square minus of E square. Okay, there's my pen. Okay, this one. Okay, it means according to Pythagoras theorem we are just writing this one. Okay, it means combination of these two is equal to this one. Okay, L plus R the whole square minus of V square. Either both the stroke length. Okay, this entire thing. So whenever you just go for the extreme left portion also little bit of same like this it will be. Okay, this one L minus R the whole square minus of V square. So while you just calculate we will get the stroke length. Okay, this is the entire thing. Okay, I think you can understand. So suppose if there is an offset of distance means E is there, offset of distance means for that quick return ratio equal to 180 minus plus of alpha divided by 180 minus of alpha. So quick return ratio equal to 180 plus of alpha divided by 180 minus of alpha. Okay, I think so you can understand. So you can see radius plus eccentricity less than or equal to L. Okay, it's about generally not possible. It means just not thing. So you can see whenever I think you can see guys 55 less than it is not possible. It cannot rotate because the connecting rod doesn't need to be such a here. It means it should be a length distance. Okay, you can see for the next offset mechanism. So eccentricity is given. Okay, then it is offset. Okay, it means offset mechanism. So for this you need to calculate the extreme length and extreme stroke length mean LS. Okay, LS what? I think so I already told you this formula. Okay, just put length, radius and necessity put here and calculate, we will just get the stroke length. Okay, so next one they are asking the quick return ratio. So quick return ratio is what I just told for offset 180 plus alpha divided by 180 minus of alpha. So how we need to find alpha equal to what? Beta plus 180 minus of gamma. Okay, 1 second. Yes, that was the thing I was thinking. Okay, guys, it's anyway it's our wish. Okay, suppose if you want to find like that also you can just find. If you want to find like something you can just find. Okay, or you can see other thing. So what is this thing? 180 plus of alpha, this one 180 minus of alpha. So you can see this difference we can easily find out. Okay, so alpha is this one, this and this. Okay, I think so got about. So you can see alpha, this is stroke length LS. So this one is alpha, you can see this one is L minus alpha, this one is L plus alpha. Okay, I think so got the point. So calculate L plus alpha, it means L plus of the whole square plus of L minus of R the whole square minus of L stroke length the whole square divided by 2 times of L plus of R L minus of R. Okay, just calculate the value and put here we can calculate the each and everything. Okay, so now we can say guys by changing the geometry of mechanism the quick return, yes, by changing the geometry of mechanism now the quick return ratio is also changing. Okay, so you can see this one is inline sliding mechanism, so essentially it means 0. So you can see what is the number of link is 4 link and turning point 1 2 3 3 and the sliding point is only 1. Okay, so what is the degree of freedom? Degree of freedom as I told 3 n minus of 1 minus of 2 times of 0. Okay, so 3 4 minus 1 3 minus of 2 times of, so how much joint is that? 4. Okay, so 9 minus of 8 is 1. Okay, I think so you can understand. Okay, just one second. So inversions of slider gang mechanism is cylinder fixed, connecting rod fixed, crank fixed and different things being fixed. Okay, so second inversion you can see now we are just fixing the slider. Okay, so now slider is not moving, then actually what will move? The entire cylinder will move. Okay, I think so you can understand. Okay, so you can see the entire slider has been fixed, means the slider can't move, so only cylinder moves forward and backward. Okay, so this is called as pendulum bump. Okay, so slider can't move and only cylinder can move forward and the one turning by the race. Okay, just no normal. So here what will happen here, it means 2 is the shortest link, so opposite to the shortest link we are just fixing this one means, so what will happen, the entire thing will be rocker mechanism. Okay, so it is pendulum. Okay, 3 links rocker. Okay, I think so about the point. So next one is we are just fixing the cylinder. Okay, whenever we just fix the cylinder, you can see whenever you are just fixing the cylinder means you can see here the entire thing will be is like a oscillating one. Okay, it's like a pendulum only. Okay, I think so you can see this. Okay, like this only the actual thing will be. Okay, so next one fixing the connect. You can see fixing the connecting rod means what will happen. So you can see adjacent to shorter string is being fixed means one will be crank and other will be rocker. Okay, I think so you got the one. So it is called as oscillating cylinder engine. Okay, I think so you got it. Oscillating cylinder. So this entire cylinder will just move forward and backward. Okay, so this thing was used in the earlier steam engine, but now it has been not because it is difficult engine and it's so much complicated and huge dynamic forces involved. Okay, and this comes under the category of power producing cycle also. Okay, so next one you can see power absorbing cycle. Okay, so power producing cycle and power absorbing cycle also different kind of thing we are just going over. Okay, and we can also just make it differently. Okay, you can see this one. So it is in this one what is mean fixed, connecting rod is fixed. So whenever the connecting rod is fixed means you can see the small link moves down and forward. Okay, so this is an actual case scenario. So this one also same, but this one we just it is kinematically present, some different one, both are kinematically same. So you can see 2 will rotate completely. Yes, 2 will rotate because adjacent, and the slider crank it means slider is fixed. Okay, 2 is crank oscillator, so it is crank rocker mechanism. And connecting rod fixed means it is crank and slaughter lever mechanism. Crank and slaughter lever mechanism. Okay, I think so you're getting the point. So in this case it's so much simple. Okay, so it means if eccentricity is equal to 0, 180 plus 2 pi minus half alpha divided by alpha. Okay, if eccentricity is some distance, what will be the 180 plus of alpha divided by 180 minus of alpha. Okay, so if eccentricity is there and as well as if connecting rod is fixed means what is the equivalent ratio, 360 minus of alpha divided by alpha. So alpha should be in which format, in the degree or any kind of angle format. Okay, so this is the extreme thing. Okay? You can see this one, the smaller angle moves here and moves here. Okay, I think so you're getting the point. So this is entirely is 360 and 360 minus of alpha divided by this one alpha. Okay. Extreme right and extreme left. So extreme right as well as extreme left, we just measure the distance. So in this case each and everything the stroke length is so much important. Okay, because without stroke length we can calculate each and everything, we can't calculate. Okay, I think so you're getting the point. Okay, so you can see crank 2 and slider 1 should be in a circle and extreme right position the following. Okay, so stroke length, yes, definitely. So you can see this one, return stroke is alpha divided by omega and forward stroke is 360 minus of alpha divided by omega. Okay, so what is the equivalent ratio? 360 minus of alpha divided by alpha is the equivalent ratio. So now we are just seeing the entire thing. Okay, so as I just already mentioned about this one, so I'll just draw the diagram. Okay, so this entire thing is stroke length LS. Okay, you can see this entire alpha is, this one is alpha divided by 2, this one is alpha divided by 2. Okay, so you can see this one and this entire. So what is this entire thing? It is connecting rod, length of connecting rod. Okay, so what is this one? This one is the, it means this is stroke radius. Okay, stroke radius. This one is, it means oscillating length. Okay, so based upon this you can see this is opposite adjacent hypotenuse. Okay, so suppose we just measure this entire distance means you can see this one. Okay, this one is alpha by 2. Okay, I think you are getting the point. So we need to just visualize it. Okay, okay, I think so you're getting the point. So I'll just draw this diagram. So alpha by 2, this one is stroke length, it means stroke radius, and this one is connecting rod, and this is it means this one not that much in. Okay, so opposite adjacent hypotenuse. So cos alpha divided by 2 equal to adjacent of radius divided by L of fixed. Okay, this is one formula. Okay, I think so. So alpha by 2 equal to cos inverse r divided by L of f. Okay, put alpha here, it means 2 here, when you can calculate alpha easily. Okay, so next one is so same this one. So you can see this one is theta, this one is 90 degree. Okay, so what is this doing? So 90 plus alpha by 2 plus of theta equal to 180. So theta equal to 190 minus of alpha by 2. So this one is 90 minus of alpha divided by 2. Okay, okay. So you can see it means where is that one? Okay, so this entire thing is 90 minus of alpha divided by 2. This one is 90 degree. Okay, so you can see this one opposite adjacent hypotenuse. Okay, so here sine will come. Okay, sine of 90 minus of alpha divided by 2 equal to this entire, it means stroke length is half. Okay, ls divided by 2 divided by, it means this one length of slaughter. Okay, this one length of slaughter. Okay, length of slaughter. So sine 90 minus of L by 2 equal to ls divided by 2 times of length of slaughter. Okay, this is also one of the most important. Okay, okay, so we can also represent sine 90 minus of alpha divided by 2 as cos alpha by 2. Okay, I'll just show you the formula. So you can see this one, sine 90 minus of theta equal to cos theta. Okay, so sine 90 minus of alpha divided by 2 is cos alpha. Okay, alpha divided by, so cos of 90 plus of theta equal to minus of sine theta. Okay, I think so you are able to understand. So you can just go for the next one. So you can see guys, two quick ratio is simple thing. So time required to cutting divided by time required to return. Okay, so mostly the return time should be so much lesser. Okay, so in this one you can see which one has a quick ratio here. Okay, so it means what is the formula? 360 minus of alpha divided by alpha. Okay, so quick ratio. So if you can see alpha increases, what will happen? So the quick ratio decreases. Okay, if q decreases, it means this alpha decreases, the quick ratio is so much higher. Okay, same. Okay, so it means we are just seeing different format. We are just seeing with respect to radius. Okay, so how the radius will be, so what is the relation between radius and alpha? So you can see this guy is cos alpha divided by 2. For example, cos alpha divided by 2 equal to r divided by L of x. Okay, L of x is always fixed. Okay, but while it means while radius changes, definitely r also might changes. Okay, according to this formula, alpha also changes. Okay, r changes, definitely alpha also changes. Okay, so many people might ask, okay, this one is r, okay, this one is alpha, so same like this. This one is 10 degree means this one also will 10 degree. Yes, it will be, but according to the real case scenario, each and everything will keep on changing. Okay, okay, so you can see here 10 is there and here 20 is there, means there will be occurring a difference. Okay, so alpha is a function and the radius less, stroke length also less. Okay, okay, I think so. Why? Because the radius also one of the most important factor that we need to see. Okay, if radius is less, alpha, it means radius is less, what will occur? Stroke length will be less. Okay, alpha will be more. Okay, if radius is more, stroke length will be more and alpha is less. Okay, I think so. You can see this one will be so much beneficial for the quick ratio. Okay, so that's why in the most of the machine we just use only the radius more and stroke length will get also more and that alpha will be less. Okay, so influence of crank radius on the performance of mechanism. In a crank and starter device, quick return mechanism, decrease of crank radius, keeping all mechanism. Okay, this is a normal thing. Okay, so you can just see some of the questions. So you can see in a crank and starter device, the distance between fixed center. Okay, so length of the this connecting rod equal to 300 mm. Length of driving crank blade is equal to 150 mm. Find the inclination of the slotted lever mechanism. Read extreme position, also find quick hit ratio. So they are asking what is the thing. So they are finding inclination of the slotted lever in the vertical axis in the extreme position. So this one theta is also they are asking. Okay. So as well as the quick hit ratio. So what is the formula? So cos radius should be length of connecting rod. So by this thing I think so you can be able to calculate the formula. It means alpha easily, and quick ratio of this one is what, 360 minus of alpha divided by alpha. Put here we can easily calculate. So what is the theta? So 90 degree, this one is alpha divided by 90 degree, this one is theta. Okay, so theta equal to 90 minus of alpha divided by 2. Okay, so alpha is 30 degree, means alpha divided by 2, we can just calculate easily. Okay, so next one you can see connecting length is 560 mm crank length. Okay, quick ratio, find the distance between the centers. So they are asking the stroke length, LFS. So LFS how much? So length of crank, so first thing it's the length of slotted lever is 250 mm. So find the radius. Okay, so I think so alpha we can just easily calculate by this one. Okay, alpha calculate, and by this you can see we can calculate the length of connecting here. Okay, length of connecting, just go and place here and you can calculate each and everything. Okay, so next one you can see now what we have just did, we have just fixed the crank. Okay, crank fixed means definitely there will be two, what will happen, two crank rotation will be. Okay, no, it means 360 degree of rotation will be completely in the crank. Okay, so you can see each and everything is shortest link is fixed. 3 and 1 are fully rotatable. Okay, so we get two circles. Okay, and 4 and 1 will be slotted lever. No, because it's connected to shorter link, so it can't rotate fully. Okay, so it is called a slotted link. So you can see 3 is driving crank. Okay, 360 and it means the amount, it means the press is given in 3 and 4 and it goes to 1. Okay, so this is the entire thing. Okay, so this is called as Whitworth quick return mechanism. So I'll just show you the diagram.
The Whitworth mechanism is a device that's used to convert rotational motion into reciprocating motion with the unique feature that the return stroke is faster than the forward stroke. For this reason, it's also called a rapid return mechanism. The angle of the blue arc is much smaller than the angle of the orange arc, and so the arc moves from left to right faster than it moves from right to left. This mechanism is used in machines designed for cutting and shaping objects.
Okay, so you can see guys, as the shortest link has been fixed, what will occur? So 360 degree of rotation is occurring. Okay, so you're able to understand. So for this also, what is the quick return ratio? Is 360 minus of alpha divided by alpha. Okay. So here guys, in general, in the forward stroke, the tool moves so much forward. Okay. And in the backward stroke, the tool becomes so much quicker. Okay. So extreme right and extreme left, I just showed to you. Okay. So in this, just you want to remember the formula. So d forward equal to 360 minus alpha divided by omega. This one. Okay. I think so you're able to get the point. Okay. So what are the extra things? Okay. So you can see based on rotation, the cutting and return tool position changes definitely. So you can see this entire thing. Okay. So it means cos. I think so you can remove this one. Okay. Alpha by 2. This one is alpha by 2. So cos alpha by 2 is this one is opposite adjacent hypotenuse. So length of fixed crank divided by length of driving crank. Okay. So cos alpha divided by 2 length of fixed crank divided by length of driving crank. Okay. So quick return ratio is 360 minus of alpha divided by alpha. So extreme portion 1, extreme portion 2, and distance between them is stroke length. Okay. Extreme portion 1, extreme portion 2, distance between them is stroke length. Okay. So length of stroke is diameter of external length. Okay, diameter. Okay, just a basic thing only. I think so you can understand. So here it means generally the stroke length will comes as a stroke LS is 2 times of radius. Okay, stroke length is 2 times of radius. Okay, in this around case. Okay, length of stroke is diameter of external length. Okay. Okay, let's just have just 2 minutes of break. Okay, after that we can just continue remaining other things. Okay. Okay guys, let us start. Before that I will just think. Okay guys, you can just start. Okay. So now it means what we are just doing, you can see here slider crank signal slider. So we are just fixing the shortest link. Okay. So in before thing also it means without quick return mechanism only the shortest link has been fixed. In similar to that, here also we are just fixing the shortest link. Okay. So what are the things we are just going to apply? You can see this one. Without quick return mechanism. Road changing mechanism. Okay. I think so you can able to imagine. So you can see guys, in this behind the distance will be fixed. Okay, but each and everything is been moving. Okay. Okay, you can see this one. Okay, see this is been fixed. Okay, but remaining each and everything is been moving. Inversion single government chain. Okay, जो me chain. Okay. So generally it means in old type of aircraft, lot of like this kind of thing is being used. Okay, so single slider fixed and connecting rod fixed, transfer tank fixed. Okay, so whenever we just fix slider or cylinder, we just get pendulum pump and piston cylinder. It means reciprocating engine, compressor pumps and IC engines. We comes this one cylinder. So whenever the slider has been fixed, we get the pendulum pump. Whenever the connecting rod is fixed, which what we get slider crank mechanism. It means what is that one? Sorry, you want to see crank and throttle level mechanism. Okay, so crank is fixed. We cut with short quicker mechanism as well as the gonome engine. Okay, or rotary engine. Okay, so you can see in turning point friction is less, but when comparing to sliding, So turning point friction is little, but in sliding point the friction is so much higher. Okay. So now for that we are using the double slider crank mechanism. Okay, double slider. Okay, so you can see guys here are 3 turning pair and 1 sliding pair will be, but here 2 turning pair as well as 2 sliding pair will be. So you can see definitely here the friction will be so much higher. Okay, so double slider, I'll just show you the thing. So you can see this one is been moving. So okay, I think so you got the point. So this one both two is this is the comes in reality of double slider mechanism. So you can see one turning, okay, one turning pair, 2 turning pair, and 2 sliders there. Okay, I think so you're getting the point. Okay, so one, it means generally 4 links will be, it means one will be fixed and 2 slider, this one 3 slider, and center will be the connecting bar. Okay, so you can see here also degree of freedom is 1. Okay, so 2 fixed, 2 rotating. Okay, I think so you got the point. So in this thing also we are just getting 3 inversions. Okay, so first one we are just fixing the entire cylinder, it means outer portion we are just fixing one, and second one is we are just fixing the only one cylinder, and third thing is we are just fixing the turning pair. Okay, I will just see. Okay, you can see in this thing what we are just doing, we are just it means making the entire outer cylinder being fixed. Okay, while you are just making the outer cylinder fixed, you can see it's been traveling to extreme right and extreme left position. Okay, so I think so you can see this one. Okay, so this thing and this thing has been moving up, and p, and this one is y and this one is x. Okay, theta and cos theta equal to x divided by ap. Okay, cos theta equal to opposite as cos theta equal to x divided by ap and sin theta equal to y divided by. So cos square theta equal to sin square as this one. Okay, so this is the equation of ellipse. Okay, so x square ap square y square pp square, okay, equal to 1. Okay, so you can see it is called as elliptical triangle. Okay, here we get ellipse. Okay, this entire thing. So okay, it's difference. Okay, suppose you can see x square divided by a square plus y square plus divided by b square equal to 1. Okay, so you can see a equal to 2 times of a, it is semi major axis, and 2 times of b is semi minor axis. Okay, b is 2 times of b is semi major and 2 times of a is semi minor axis. Okay, so if bp distance is so much higher, we get vertical ellipse. Okay, if ep distance is so much higher, we get horizontal ellipse. Okay, basic difference, a, b and major and minor depends. Okay, okay, so it means guys so much simple. Wherever we are just drawing the point, according to that we are getting, it means we are just getting a lot of other thing. So point moves from top to bottom, vertical, circular, and horizontal. Okay, that's it. Okay, I think so this is enough. It means this enough, this side is enough. Okay, we are just going to next thing. Okay, before that just 1 second. Okay, just 1 second. So next one we are seeing fixing slider. So any slider two also. Okay, so you can see any slider we are just fixing either a slider or either b slider. So a and b give straight line. Okay, point b c will give circle or ellipse. Okay, so you can see this one either 1 2 slide 1 2 3 everything. So we are just fixing one side, means what will we will get elliptical triangle. Oh, sorry, we will get square ellipse. Wait just 1 second. So I think so you can see this one. So this one is cardiac mechanism. Okay. Okay, see how it's been rotating. Okay. Okay, I think so you're getting the point. Slow fixing the slider. Okay, any slider 2 or 3 we are just fixing, according to slider we are just seeing. Okay, you can see 3 4 and 2 and but 1 and 2 is sliding by another. Okay, so like this if we just getting means here what is doing, the rotation is being converted into sliding by. Okay, so it is kinematic. So it is, this is cardiac mechanism. So used in vibrations, it means simple harmonic motion, perfect harmonic motion provides. Okay, I think so you're getting the points. Okay, so you can see here, let us fix the link 3. Okay, so now the entire connecting rod means connecting link is we are just fixing. So while we are just fixing that one, what will happen? So 2 and 4 rotates independently. So when 3 is fixed, 2 and 4 start rotating independently. Okay, while the input is given to 2, it is transmitted to 1 and it goes to the 4. Okay, it is called as Oldham's coupling. Okay, it means it's just a transmission of motion from one portion to other portion. Okay, so this is called lateral misalignment, and you can see this thing, it means Oldham's coupling means. I'll just show it to you. So you can see how the alignment is there. Here the alignment is different, here the alignment is different. Okay, 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 I think so. So this is called as Oldham's coupling. Okay, one side will be different time, one side will be different time. Okay, so we'll just comes across each and everything. Okay, slide single side everything is cylinder. Just by changing IC and converse shortest link which was so connecting rod oscillating a clank grand slider. Okay, if slider is fixed, you can see hand pump or pendulum pump. Okay, if a double slider has been there, first link has been fixed, it is called a slaughter and elliptical. So length 2 is fixed, it is called arches. Link 3 is fixed, it is called Oldham's coupling. Okay, which of the following is the inversion of slider cam mechanism? Single slider cam hand pump. Okay, so in elliptical double slider will be there. Okay, so in slaughter lever and quick slip mechanism, so the beginning and the end of shows occurs when, so in slaughter lever. Okay, slaughter lever crank lever or in line, no, crank is horizontal, so crank is perpendicular to the lever. Maybe B option might be. Okay, so conscious mechanism used to generate sine function. Okay, mechanism used in shaping machine is inversion of single side. Okay, any point on the link connecting double ellipse. Okay, so a single quick return mechanism, the forward return shock is 2. Okay, the quick return is 2. Okay, so if the radius of the crank is O to A is okay, the distance between the crank center and the lever center point. Okay, so for with the crank center and the lever center point. Okay, crank center, lever center point. Okay, this one. Okay, this one is what? Oh, they are see the that find the this. Okay, oh, it is a just definitely a tricky question. Okay, because you can see simple only they have been mentioned in nothing. So good to know to the okay. So quick ratio based upon this we can just calculate the alpha. So based upon alpha we can just calculate the length of this. Okay, I think so getting the point. Okay, so crank is not if the length of crank is half the fixed length is gone, then quick ratio is okay. So different mechanism by fixing okay different fixing different links of kind. Okay, so absolute relative motion then absolute motion is rotation means rotation only. So relative motion, so answer is A and C. How? Oh sorry. You can see by fixing different link the same relative motion or rotate over that one. Okay, then absolute motion only will change, but absolute motion changes, relative motion doesn't changes. Okay, so I can see this one which one should be what double crank. Okay, so double crank means longest link, so maybe CD. Okay, so double crank means shortest link 200 cm. I just dropped double rocker. Okay, sorry, my mistake. Scotch mechanism is okay. So the following is in motion double crank double hold-up coupling. You get okay. You see. Which mechanism is applied in slider crank mechanism when smallest link is 50 hold-up coupling and elliptical rumble. So 1 and 4. Okay, you can see in the offset slider mechanism crank does this cranking out. So stroke on. So they have just mentioned the offset. Okay, so they haven't just told about what is the offset distance is and everything. So length of is given, offset okay, offset is given. Okay, so they ask the LS. So LS equal to root of L root of stroke length. Okay, root of L plus R depends length of connecting rod plus of radius. Crank length. Okay, 2 plus minus of eccentricity. Okay, that one we just calculate each and everything. So you can see in this one, in the crank and slaughter lever type quick ratio is the length of the fixed link is AB is 50 cm. Then the crank BC is what? The crank and slaughter lever mechanism, length of fixed one AB is length of fixed one is this one. So what is the 360 minus of alpha divided by alpha. So alpha I think so you can easily calculate this one alpha. This is this because here just going to place upon this you can calculate. Okay, calculate I just put here calculate value. Okay, so that's what you can see. AC 80 D. Okay, so shortest link has been fixed. Okay, shortest link has been fixed means it is either with or quick mechanism. Okay, let us see. Driving crank is 100 BT. Okay, 180 less. So you can see it's not a mechanism. CD. Okay, so when this two times of CD. Okay, L fixed equal to 80. Driving is 80. AB is okay 100 mm. cos alpha divided by 2 is L of x divided by 2. So first calculate the alpha and you can see the ratio variation. So let's see what's so close. So how it was okay. So the ratio is fixed in OP. Okay. So in option setting the rank is rotated at constant position. Value of the ratio and okay. So they have just given definitely put here on calculation everything. So for this one I think so you can do less 180. This is being heard offset. Okay, in an offset sliding mechanism the quick ratio considered to be greater than the value of quick ratio. Okay, you can see next to 3 divided mechanism between 1 and 2 and this one between 1 and 2. Okay. Okay. Okay guys, then that's it for today's video and I'll see you in the next one. Until then, take care. Bye bye. Have a good day.